Next, last but not least, for our last part of your current of electricity chapter, we will learn about this law. It's called Ohm's law itself. Now, if you see over here, this is current passing through, is directly proportional. So this symbol that you see, it just means directly proportional itself. And one thing you need to take note is the rest are kept constant. So all other factors, your length or whatsoever, all will be kept constant. And more specifically, it is your temperature. Why? Because remember, earlier on, as temperature increases, your resistance will change, right? So you want to keep resistance the same. So what does Ohm's law actually mean? It basically is just a very, very roundabout way of saying this. I is V over R. Because if you think about it, when you have a directly proportional relationship, right? This part here is directly proportional. Basically, if you learn in maths, if y is directly proportional, it is y equals to kx, correct? Where k is a constant. So now what you want to say is basically I is V over R, right? I is constant, 1 over R V. Okay? So what this Ohm's law means is 1 over R is constant. R is constant. Okay, understand? So basically, Ohm's law just means if you obey Ohm's law, you have constant resistance. That's all. Basically, that's all it's trying to say. As long as you obey Ohm's law, you have constant resistance. If you do not obey Ohm's law, you have changing resistance. So if my current increase or my voltage increase or whatsoever, that my resistance will be affected. So if you see the left side, this is where this is directly proportional, right? I is equals to 1 over RV. All right. So your gradient is like y equals to mx. Okay. So your gradient is 1 over R. It is not R. Okay. So this is 1 over R. So if you want to find a resistance, you need to inverse it. Okay. So be careful about this. On the other hand, if they are non-ohmic, basically they do not follow Ohm's law. So you can see that your gradient is changing. So your 1 over R is decreasing for this one. Then for this one, this part, right, sometimes the school will draw it flat. So instead of a curve, instead of moving there, this part is 0. Okay, so basically you have your this part, 1 over R increasing. So because of this itself, if 1 over R on the first one, your filament length, if 1 over R is decreasing, R must be increasing because you have the opposite effect if you flip it. So in this case, R is decreasing. Okay, now what's so special about filament lamp? Now, because most of your light bulbs now, right, they're actually using LED itself, but if you're using the older filament lamp with tungsten inside, basically, right, how it produces light is using your, because it is so hot, it's glowing red hot, that it actually produces light. So it actually is affected by your temperature. So if you want to be brighter, you need to have higher temperature. And the thing is, problem is, the higher the temperature, the higher the resistance. So because you have higher resistance, your current is affected. Okay, your current will actually decrease. So the higher you go, the less current you have, and the less current you have, you will also affect your brightness as well. So there's always a certain limit. Once you reach that limit, your light bulb explodes. Okay, so it's very, very dangerous itself. And your semiconductor diode is a bit special. So to draw it, right, it looks like this. This is a diode. Okay, this is a semiconductor diode. So sometimes we just call it a diode itself. So what's the function of a diode? It actually only allows, QL, it only allows current to flow in one direction. So if you notice the shape, basically it only allows current to flow like this. So if you draw the same thing, and your current wants to flow in the opposite direction, what happens? Now, if you notice, right, it's kind of like your valve. So basically, you see this line. This line is like a gate. If you try to go here, it gets blocked by the gate. So this doesn't work. Okay, but on the other hand, if you go by the arrow side, basically you can open and they go open. So it's a one-way trip only. So this one you won't really see so early, but you'll probably see it nearer when we reach the second last chapter of set 4. Okay, so do take note about this. Basically, if you try to reverse direction, if you try to go negative, what happens is that current will be 0, or it'll be very, 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 very small to a point where it's negligible. Okay, this part is negligible current. Okay, so if you take a look at your word example over here, now the question tells you this always. Now, because of this graph, right, do take note, this is a current voltage graph, IV graph, not VI graph. Okay, so every time you look at the graph, be careful, because some schools will flip it around. Sometimes they give you a VI graph. So do be careful about it. So this is a IV graph, always double check, IV graph. And you have XYZ, you have constant resistance. That's why you see obeys Ohm's law. Okay, then Y is a filament length and Z is a thermistor. So don't need to worry too much about thermistor itself. It'll make more sense to you next chapter. So filament length basically is, if I increase voltage, I should have increasing resistance. Okay, so for your lamp filament and high temperature, high resistance, low 1/R. Okay, so not wrong word use, should be increasing. Increasing temperature, I have increasing R, I have decreasing 1/R. So the formula, the gradient itself, I have decreasing. So this must be Y. Then I'm just left with this being Z. Now, so this is your IV graph over here, right? So Y, you can see that your 1/R is decreasing, so your R is increasing over here. So how do you draw increasing R? So in this case, in our second one, basically you can see at the start, your resistance, you have a certain value, right? So it should be a line going up, because as V increases, R also increase because of this part. Okay, so for Z, Z is actually the exact opposite of Y. So if Y increases, Z must be decreasing. Can you understand? So this is your graph itself. Because if you look at Z, so for Z, right, as V increase, the 1/R of Z decrease. 1/R is increasing, right? So which means R is decreasing. So as voltage increases, the resistance of Z will decrease. So how do you draw a decrease? From the axis, you just draw down to show that it's becoming lower, lesser as V increases. Okay, so Ohm's law itself, quite a small component, but they do ask you. So depending on your school, you need to double check. Do you need to memorize this one? Okay. Other than that, it's just basically I is V over R. So that's why I say that this formula, V equals IR, is very, very important, because basically it is the same formula. Okay. So this version is called Ohm's law. This version is just your resistance. How do we find resistance? That's all. Oh, by the way, I forgot. There's one part about resistance is, if you notice, there is no instrument that you can use to measure resistance, correct? Because resistance cannot be measured. It can only be calculated. Okay? Maybe I'll write it on top. Cannot be measured. Can only be calculated using formula. Okay, we can only use the formula to help us calculate. If we don't use the formula, we cannot. There's no way for you to measure it unless you use a special device. Okay, but for now in our syllabus, we only know that your resistance cannot be measured. It can only be calculated. So you need to find your V and your I. So V, I use a voltmeter. I will use an ammeter itself.